Hi everyone, this is the Keystone IBDP Physics course. Today we're going to talk about the specific latent heat. First, let me throw a question. Do you know that while a substance experiencing phase change, its own temperature won't change? For example, when consistently boiling a kettle of water, although the water is transferring from liquid to gas, but its own temperature won't change. Wait, I can't understand this. Are you saying that the heating doesn't have any effect on the water while it's in its phase change? The heating will certainly have an effect on the substance, but not on the temperature of it. Let me be clear and please take a look at this graph here, where on the y-axis, it is the temperature of the substance, and on the x-axis is the time taken for the heating. Where on the points A and B, the substance is experiencing phase change. It doesn't have any change on the temperature, but the heating energy is kept transferring to the substance. On the right side, here's a formula representing this process, where Q is the energy added to the substance and M is the mass of the substance which changes phase. And the energy required to change a unit mass of a substance without changing temperature is called the specific latent heat. And today we're going to introduce two types of it, which is the fusion and the vaporization. The specific latent heat of fusion corresponds with here, where a substance changes from solid to liquid. And vaporization regards here, where the substance changes from liquid to gas. That is interesting. I now understand what is the specific latent heat, but why is it like that? Do you have any examples? Sure, during the phase change, all the heat received by the substance transferred to the potential energy, yet the kinetic energy remained unchanged. And if there's no change in the kinetic energy, there's no change in the temperature. And now please follow me to the lab and I'll present you some real situations. Hi everyone, welcome to the Keystone Lab, and today I'm going to demonstrate how to collect data for the calculation of specific latent heat of vaporization. First, would you move the camera closer, please? I'm going to take 300 ml of water, this much, and then I'm going to pour it into the kettle. Then I'm gonna grab the kettle and measure the weight of the kettle with water inside. So it's about 1,120 grams. And then we move the kettle back to its position and we put this vernier temperature probe, the sensor, into the kettle. Lastly, we connect the data logger with the laptop and open the logger probe. Then, before collecting data, we press the start button and start heating.
A few moments later.
Now it's the last step of this experiment. So we take the temperature sensor out of the kettle and we grab the kettle and measure its weight right now. So as you can see, it is about 1,063 grams right now. And that's all for this experiment. Okay, so today I'm gonna conduct the experiment to calculate the specific latent heat of fusion of S. The first step is to pour 115 ml of water into the calorimeter, which is isolated with the outside environment. Then we're gonna record the temperature of water initially, which as you can see is about 22.3 Celsius. After that, we're gonna measure some ice. So the weight of the ice is about 23 grams. And we're gonna put these ice cubes into the calorimeter and mix it with water. Gonna stir it a little bit. So as you can see right now, the ice cubes have completely melted. And the final temperature, which is the equilibrium temperature of this mixture, is 8.6 Celsius. And that's all of our experiment. Thank you. Hi guys, after the lab activities, I am now presenting you guys the results and data collected from these two experiments and the process of how to calculate LV and LF. To begin with, on the left side of this page, the letter D on this phase change graph shows the process of water changing from liquid to gas. According to the formula, the specific latent heat of vaporization equals to the heating energy added to the system divided by the mass of water that changes state. Therefore, the unit of specific latent heat is joule divided by kilograms. The kettle has a power of 1500 watts and the time for boiling water was 80 seconds. So the heating energy provided to water inside the kettle is 120,000 joule. And the mass of water changed from liquid to vapor was 57 grams, which can be transferred to 0.057 kilograms. By using the energy divided by the mass, we can get a specific latent heat value of approximately 2.1 million joule per kilogram, which is pretty close to the scientific value. The data collected from the other experiment is presented here that originally 23 grams of ice cubes were put into 150 milliliters of water at a temperature of 22.3 Celsius, and the final temperature was 8.6 Celsius. According to the formula, energy lost by water equals to energy gained by ice to melt and energy gained by the melted ice. After the calculation, the specific latent heat of fusion is about 3.36 times 10 to the power of 5th joule divided by kilograms. To conclude, we have learned the definition of specific latent heat, the reason why there is no temperature change during this phase change, the unit of this value, and two experiments including vaporization and fusion as examples to help you guys to understand this process. Thank you.